Hi, welcome to section 5.3, Basic Concepts of Polynomials. Now, polynomials are a special form of expression that's used a lot in math. The idea behind polynomials are the word polynomial. The word poly means many, nomials, many terms. Many terms. So a term is basically something that looks like this, where I'm going to throw one up as an example. Okay, this is a term, okay, where you have a variable. That variable could be raised to a power, like in this case I have x cubed. It doesn't have to be raised to a power. It could be raised to the first power. Like in this case, this is x to the first power, to 1 power. But, you know, the 1 power is just not written down. It's assumed to be there. So in this case, a polynomial can have a variable raised to a power, and there could be a number in front of that power, in front of that expression, and that number is called the coefficient. So here's an expression that is x to the first, and the coefficient's 29. Is this a polynomial? Well, a polynomial can consist of one or more terms. In this case, you separate your terms with a plus or minus sign, like 3x squared minus 2x. Now, this is a polynomial. This is a polynomial with 3 terms, and each individual term, or nomials, represent that same format. A variable, power, coefficient. Variable, implied power, coefficient. In this case, the coefficient would be minus 2. It's always the number with the sign in front. This is a polynomial. It doesn't look like one, but it is. It's just one term. There's no need for pluses and minus signs, and it follows the pattern. Coefficient, variable to a power. That's all you're looking for. All right, and so now the next one. Now this is not a polynomial. You can't have weird operations inside the polynomial. You can't have, this is a square root, and I don't believe we talked even about square roots, and that's one of the more bizarre operators that you're going to see in algebra. But it's you can't have that. You can only have variables raised to a power. So that's good. That's good. That's what you do here. And you cannot, this is not a polynomial either. Okay, the power has to be an integer, has to be a whole number. 0.3 is not a whole number, so nope, you can't have that either. So they're a very specific type of expression that you're going to see a lot of. Classify the polynomial to the number of terms. Well, each term has to be separated with pluses and minus signs. So here's a term right here, always with the sign, minus another term, that's a second term, minus another term. So I would say there's 3 terms there. Okay, to get rid of these the pluses and minus signs, separate the terms. And in this minus sign doesn't separate anything. It's just the fact that the number in front of that p cubed is minus 8. But this is what you do. You just understand that pluses and minuses separate terms. And if that's the case, you got 1, 2, 3 different terms. That's a trinomial. Okay, this chapter should go really quick. Now rearrange the polynomial in descending order and then identify its degree. Now, this is a polynomial, but it's not written in an acceptable fashion because mathematicians like to organize things. And when you organize 1, 2, 3, 4 terms, they got to be in the order of highest exponent down to lowest exponent. So I see the highest exponent being this guy, 4x to the 5th power. That's got to go first. The next highest exponent is x cubed, so I got to make sure I go down to that level, plus 4x cubed. Okay, where's my exponent? 3. Now, the next highest exponent is a 1, and so I would say that's 4x minus 4x. Excuse me, minus 4x. It's always with the sign. But don't think that the number in front of the x is 4. It's not, the number in front of the x is not 4, it's minus 4. So I'm going to write down minus 4x. It's always with the sign. Understand that. So the next thing is 5 plus 5. And now you might think, well, geez, 5 is a term? It certainly is. It's x, 5x to the 0 power. Okay, that's what 5 is. Anything to the 0 power is 1. 1 times 5 is 5. Of course, you're not going to write that. You're not going to write that. What you're going to do is just simply write 5. But I wanted to show you that, yeah, it does follow the definition that anything you have to have a number, a variable raised to a power, and that power better be 0 to whatever. It's got to be a positive number. Okay, so that's done. Let's check my answer. Looks like it's right. Now, over halfway done now. Number 6. What did I do? Oh, there's another part to this. The degree of the polynomial. Okay, the degree of the polynomial is the highest power x or variable you see. Now, the highest power variable I see is the 5. Now, if you rearrange it properly, it's the power of the variable in the very first term. So it'd be x to the 5th. I would say the degree of the polynomial is 5. Now, let's check my answer. Well done. Super duper. Now we're over halfway done. Now, this guy here seems to be a multi... Yeah, there's 4 different expressions here. 4 different things bundled in one problem. So let's see what that looks like. Okay, this is a polynomial. That's good. The constant term is just a raw number with no variable. So the constant term of this polynomial would be 3. The leading term, okay, here's your polynomial. The leading term, and it's written properly, high exponents down to low exponents. The leading term would be 6x to the 6th. That would be the entire term. And the leading coefficient is just a number in front of that leading term, 6. Let's check that answer. Great, great. These are just terms that you should understand by looking at the polynomial. Identify what the leading coefficient is. These are things that you, and what the leading term is. You need to know these things when you do the future assignments. Okay. This is a polynomial. Doesn't have any powers in it, but it does. Implied there's a power of 1 here. The constant term is the -9. Remember, when you're dealing with this, it's always the number with the sign in front. It's -9. I can't emphasize that enough. The leading term is minus x. This is the leading term. And minus x implies that there's a -1 number in front of the variable, so the leading coefficient is -1. Check your answer. Fantastic. Okay, now be careful here. This is not written correctly. So what I'm going to do to answer these questions is you've got to make sure they're written correctly. So I'm going to let me clear this out. Clear this out, don't save. File, new, and start off a new virtual sheet of paper. And come over here and say, well, this should be the highest exponent term, should be the x squared. The next highest would be the -8x. And then we've got the -5 at the end. That's written right. Now, once it's written correctly, you can answer these questions. The constant term, -5. -5. Let's see, what's that? Leading term. The leading term is x squared. X squared. The whole term. And the leading coefficient is the number in front of that leading term. If there's no number there, it implies 1. 1. Check your answer. Nice. Very good. And then I think this is the last part. Is this in the right order? Yep, it's in the right order. The constant term is the last number, +4. Don't need to write the plus. Leading term is the front term, -9. X raised to the 4th power. And the leading coefficient is the number in front of the leading term, which is the -9. Check your answer, and we're done with that problem there. Okay. Number 7. Oh, there's 1, 2, 3, 4, 5, 6 terms in this expression. But you don't really need 6 terms to represent that, because there's something called the likeness, like terms. And when you see like terms, you can combine like terms together into one. Now, what makes a like term? What makes a like term is you have to have the same variables, the same variable, and the same powers. Like in this case, I see an x cubed, and I see a 6x cubed. I'm sorry, z cubed. I see a z cubed and a 6z cubed. Those guys here are like terms because they have the same variable and the same powers. So we can combine those. We have one of these z cubes plus another 6z cubes, which leaves you with 7z cubes. In fact, you know what I'm going to do? I'm going to put these problems here. It might be best to just show you here. -3x squared plus 6 plus 6z cubed plus 11z and plus 3. Okay, 6 terms. This guy and this guy are like terms because they have the same variable, same powers. One of them plus 6 of them is 7 of them. That's what we have here is 7z cubed. So I can get rid of this, and I don't want to look at those anymore because the end answer includes those. You go in the order of your exponents. I see a square here as the next exponent. Do you see any x squared terms anywhere else? Nope, I don't see anywhere else. So I'm going to put down -3x squared. Okay, it doesn't combine with anything else. Okay, so let's get rid of that. Okay, and do we see anything else? I see 11z. Do you see any other z's? No, so far, the only thing that looks like it might be like terms are the cubes. Okay. 11z. So I took care of the z term. And 6 and 3 are raw numbers. They're like terms. You combine them. 6 plus 3. You always go in left to right order when you do your operations. 6 plus 3 is going to give you 9. So what I have here in 4 terms is exactly the same as what we had originally at 6 terms. It's just much nicer to write that down. So let's write down the 7z cubed. Bring it down. Minus 3z squared. Bring that down. Plus 11z plus 9. Check your answer. Great job. Just 4 more problems. And math is big on evaluating polynomials. What they want you to do is you start off with a polynomial and you think of this as a template. And they ask you to plug in for the variable a particular value, and they call that evaluating that. So here's what you do. We'll use the same amount, the same paper. Here's your template, 5x minus 2. Evaluate when x is 0. What you want to do is everywhere you see an x, what you want to do is plug in 0 for x, but make sure you plug it in with parentheses, Don't simply do this, because that looks like the number 50. You don't want that. It's 5 times 0. Make sure when you plug in the variable, the value, you plug it in with parentheses around it, minus 2. And then you got order of operations to perform. You got to do the multiplication first before you do any subtraction. So I got to do 5 times 0 is 0. 0 minus 2. And certainly 0 minus 2 is simply going to be minus 2. So I'm going to plug in minus 2 over here. Check your answer. Excellent. Now, what happens when we plug in minus 1? See, this is the template right over here. I'm going to plug in minus 1. And make sure you put parentheses around it because it looks like it's 5 minus 1. You don't want that. Now it looks like what we're supposed to do. Minus 1 is got to be multiplied by 5. Okay, copy the rest down. Multiplication first. Minus 5 minus 2. Minus 5 minus 2 is minus 7. Check your answer. Great job. Great job. Next question. All right, now we want to evaluate a more complicated polynomial, but it's the same thing. But it's a little bit more complicated, so we'll need a little bit more paper, virtual paper. So I'm going to come here and write that down. What I first do when I do these evaluation problems is I write the template down. This is my template. Okay, evaluate for x equals 1. Everywhere you see an x, you put 1 in parentheses. Order of operations. Powers first. 1 squared is 1. You do multiplications next. Well, let's do one operation at a time. We'll do that we did one operation at a time. We did the power. Next we do the multiplication. And when you multiply, it's not 6 times 1, it's always with the sign. So it's negative 6 times 1, which is 1 minus 6 minus 6. And now we're left with minus signs that we do in left to right order. So we got to do this one first. So 1 minus 6 is minus 5. Bring down the rest of the expression. So minus 5 minus 6 should give me a minus 11. Minus 11, hit enter. Great. Now, instead of 1, you plug into your template up here a negative 1. So everywhere you see an x, you put negative 1 in parentheses. Minus 6 times negative 1. Minus 6, that's I plugged in. Powers first, order of operation. You do your powers first. Negative 1 times negative 1 is 1. Copy the rest down. Multiplications next. Negative 6 times negative 1 is 6. 6. 1 plus 6 minus 6. Okay, then you do your operations from left to right. 1 plus 6 is 7. Minus 6 is going to give you the value of 1. So that's how we evaluate expressions. Nice. 2 more problems. Combine like terms. Okay. Here's what we're going to do. I don't think we need to write this. I look for the highest powers in my expressions. I see squares. H squared, same variable, same power. What you do is you say 7 of those h squares minus 1. So you always go left to right order. So 7 minus 1 would give you 6 of those h squares. And so we're done with the square terms. Next we look at the next power, which has to be a power of 1, h's, just plain h's. You got negative 6 of those h's. Minus 2 of those h's gives you minus 8 of those h's. So we took care of those. What's left over then is the negative 13 plus 6. Negative 13 plus 6 is negative 7. And this is good. So we got 6 terms down to effectively 3 terms. That's what math is all about. Simplification. And last, oh boy, this is a serious problem right here. We got cubes, we got squares, we got x's, and we got numbers. So we start off with the cubes. Same variables. Z cubed, so you got 8 of them. Minus 1 is 7 of those z cubes. Okay, so the cubes are done. Then we look for the next power, which would be squares. So I see a square here and a square here, z squared. So negative 3 plus 16 is plus 13 z squared. So we took care of the squares. Then do we have z's? Regular z's. Regular z's. I just see one z, unless my eyes fail me. One z. That's it. If you only see one z, you have to include it, but it doesn't combine with anything. And last would be just raw numbers. Plus 5 would be plus 10. And this thing looked really 1, 2, 3, 4, 5, 6, 7. 7 terms down to 4. That's pretty simplified. There you go. Those are basic concepts of polynomials, and we'll see you in the next homework assignment, section 5.4. Take care.